Now in this diagram, the timeline of impulse transmission in the heart is shown. Okay, so the impulse originates in the SA node. So this is, like you start the time from 0 second. Okay, 0 from 0, and now this impulse reaches the AV node in about 0.03 second. Okay, and then the impulse is delayed in the AV node and the bundle of His, and by the time it enters the septum of the ventricles, 0.16 second has gone. So there is a delay of about 0.13 second in the AV node and the bundle of His. Okay, and by about 0.16 second, after about 0.16 second, it enters the in the septum, interventricular septum, and then this impulse passes through the septum and moves towards the apex, and then first the endocardial surfaces are depolarized. I've already told you, and in about 0.19 seconds, okay, 0.19 seconds, okay, the inner sides of the ventricles, they are deeper by 0.19 second. Okay, now that means it takes about 0.16 over here. Okay, at this point 0.16 and 0.19 second is at this point, so it takes about 0.03 second for the impulse to pass from this septum towards the inner surfaces of the heart, and then this impulse passes from the inner surfaces, that is the endocardial surfaces, to the outer surfaces, that is the epicardial surfaces, in another 0.03 second. So that means that the impulse which was started in the SA node reaches the last ventricular fibers in about 0.22 second. It takes about 0.22 second, okay, for the impulse, okay, to reach from SA node till the last ventricular muscle fiber, 0.22 second. Okay, now this is the table showing the different parts of the heart and their velocity of conduction. So the velocity of conduction varies from one part to another. Okay, as you can see, the velocity of conduction is the slowest in the AV node. It is slowest in the AV node, which is about 0.05 meters per second. But at the other extreme, you can see it is fastest in the Purkinje system. Here in the Purkinje system, the velocity of conduction is fastest, which is about 4 meters per second. So the conduction rate or the velocity of conduction varies from one tissue to another tissue in the heart. The slowest velocity is in the AV node, where the delay takes place, the AV nodal delay, which is very important. I've already told you that. And the fastest velocity is in the Purkinje system, and this fastest velocity, this high velocity in the Purkinje system, ensures that both the ventricles are depolarized at once instantaneously, so that both the ventricles can contract instantaneously, simultaneously, at once, rapidly, so as to produce a pumping effectiveness.